All right, this video is going to be talking about the nuclear equations practice problems from the homework packet. The first problems that we're going to do is from page 1, and these are the that you'll have to fill in, so go find these numbers of 1, 9, and 22. The first one we're going to do is 1. So in order to solve this, you're going to have, basically think of it as like a basic algebra problem. So on the top one, I'm talking about 42, this, plus, and then I'm going to say x, okay? So we end up with 42 equals 0 plus x. And so x equals 42. So then what you're going to do is you're going to write 42. The next thing that you need to do is the denominator. And so that'll be 19 equals negative 1 plus x. So make sure with these negative ones, gets confusing to a lot of students. So maybe even write it down or do the math afterwards just to check. So I'm going to have to actually add 1 to both sides. So I've got 20 equals x. So I'm going to write 20 on the bottom. And just recheck your work. So is 19 equal negative 1 plus 20? Yes, it does, so we're good. So now you're going to look on your periodic table for the for an atomic number of 20. We always base it off the atomic number. And so when you look at 20, you're going to write down Ca. Okay, so you're going to have 3 pieces of information for every single one of these: a mass, a charge, or a mass, a proton count, I guess, or charge sometimes depending, and then what element you're talking about. Now the type that you're going to be looking for is, first you have to identify what one of those weird particles, so we've got alpha, we have beta, we have gamma, we have neutron, and we have positron. Okay, so which one or ones of these particles do we see? So we see this guy right here, which adds up, which equals your beta. So you're going to write down beta. And now what you need to do is identify whether it is, hold on, I'm going to erase this stuff, A, B, C, D, or E. So identify what side the beta particle is on. The beta is on the right side, so you have to choose D or E. And D stands for decay, E stands for emission. Does not matter what you choose, so I'm going to do beta decay. Okay, you just can't do absorption, bombardment, or capture, okay, because that would mean that the beta particle is on the left-hand side. Let's try number 9. 9 is, okay, so we got a little bit trickier one with this guy, okay, so we are going to have to, that's why I have this one, so we have 235, just doing the top, plus 1 equals 142, and here's where the tricky part goes. This is actually saying we have 3 neutrons. So it looks something like that, right? But instead of writing all those separately, what they do is they combine them. So if I added up all of these guys, what mass would I get? Well, I would get the same mass as if I did the 3 times the number. So 3 times 1, so plus 3. And then we've got plus x. So I'm going to condense a little bit. So we've got 236 equals 145 plus x. So now I'm going to subtract. I'm going to take 236 minus 145, and I get 91. So 91 equals x. So I'm going to write 91 on the top. Now I would do the exact same thing for the denominator. So we have 92 plus 0 equals 56 plus 3 times 0 is 0 plus x. So we're going to take 92 equals 56 plus x. So I'm going to subtract 56 from both sides, and we get 36. So we're going to get 36. And now I'm going to look up what 36 on the periodic table is, and it's Kr. Okay. Now, in this class, whenever you see a neutron, what you're going to need to do is you're going to identify it as either going to be fission or fusion. That's it. Even if I have an alpha particle, even if I have a beta particle, anything else, if I have fission or fusion, or if I have a neutron, I'm going to automatically just write fission or fusion. And there's no decay or emission or absorption for this. It's just literally the words fission or fusion. So what you want to do is you have to identify whether it's fission, which is division, which means I go from one thing to two things, plus, like one large thing to two smaller things, or fusion where you're fusing things together, so I go from 2 smaller things to 1 bigger thing. When you're trying to identify this, what you need to do is you cover up all your neutrons. So I'm going to scribble them out. They still count towards like the masses and stuff like that, but when you're trying to identify fission or fusion, you're going to just like cover them up or whatever. So I've got one thing, then I've got my arrow, and it is going to 1 two things. So one thing going to 2 is my fission reaction. So I'd write fission. Okay, now let's try the next one. The next one is we've got 31 plus 1 equals x plus 28. So 32 equals x plus 28. So x equals 4. So I'm going to put 4 on the top. On the bottom, I've got 15 plus 1 equals x plus 14. So 16 equals x plus 14. So x equals 2. All right, now what you need to do is you can look on your periodic table and you can see that it's HE. You also sometimes will get zeros, and whenever you get a zero either on the top or the bottom, you are going to have to memorize these and put them down as either a beta or a positron or a gamma or like a lowercase n for the neutron. So make sure that if you ever see a zero, you know you're going, like when you're solving for the unknown, you know you're going to be using one of those guys. All right, so now we have to identify the type, okay? And the type is I see an alpha particle, and the alpha particle, so I'm going to write alpha, and the alpha particle is on the right-hand side of that arrow. So I can either do decay or emission. I always choose decay because it's shorter. And so you would do alpha decay. By the way, if you ever see the word electron instead of beta, that's fine. Just you can use electron instead of beta. Typically they use it if it's on one side versus the other, but it doesn't really matter, okay, for this class. All right, so now we're going to be working on practice of the word problems, which is found on page 2. Okay, so the first problem says write a nuclear equation for the alpha decay of 23191 Pa. So because it's the decay of this, that is what we are starting with. That of means that we're starting with it. So I'm going to write 23191 Pa. Okay, now what you're going to try to figure out is the alpha, you know it's an alpha particle, and what side is that alpha particle going to be on? Well, you look at that decay. So remember A, B, C, D, E. So D is on the right-hand side for decay. So I'm going to put my alpha particle, which is this guy, on that side. Now I just need to figure out my other guy. Okay, so we've got 231 equals 4 plus what number? And so that would be 227. And then on the bottom, we've got 91 equals 2 plus what number? So that would be 89. And so you would look up for 89 on the periodic table and you get AC. Okay, write a nuclear equation for the beta emission of that guy. Once again, it's of this guy, so that means that we're starting with that. So it's 22387 FR. And we need to do an emission, which is on that right-hand side because it's that E. And so we're going to put a beta particle, which is a high energy electron. And then we have to figure out what the other guy is to make sure that the math fits and solves. So we've got 223 equals 0 plus what number? So that would be 223. And then we have 87 equals -1 plus what number? And that would be 88. And so you're going to look at 88 on the periodic table and you get RA. Okay, and then the last one, write a nuclear equation for the alpha absorption of that guy. So once again, we're going to be starting with that one, which is 14962 SM. And we are now doing absorption. So absorption is found on the left-hand side. So I'm going to put my alpha particle on this side because it's telling me that the alpha is on the left side by that absorption. And I'm going to do 149 plus 4, so that is 153. And then 62 plus 2, which is 64. And then we're going to look on the periodic table for 64. And 64 is GD. So there's your answer. All right, next page. This is a pretty easy chain reaction. What a chain reaction is that what it says is that the products then become the reactants. So what you ended with is what you start with for the next part. It's kind of like a domino effect. So what you end with is now the starting substance. So if you look at this A then becomes the starting substance here. If you look at B, it becomes the starting substance here. So we'll do the first one together. And so we get 23491 Pa equals 0. So we're going to do 234 on the top. And then 91 equals -1 plus, which is 92, and that would be U. So now I'm going to put 234, 92U for my starting one. See how the C then correlates with that C? That's the only thing that those C's are trying to do, is tell you, hey, those line up. And they're going to be the same answer. So now we're going to try to do the next one. So 234 equals 0 plus what number? So that's 234. 92 equals -1 plus what number? That would be 93. So you're going to look up 93 on the periodic table, and then you get NP. And then this will carry on to be the starting substance of the next one. On that same page, we're going to be doing the isotope type of decay and isotope produced. This is actually two separate problems. This, let's say, is number 1. This is number 2. So the first thing that you need to do is figure out what the heck this general thing is saying. So this is isotope. That's what we're starting with. Decay. Okay, so these are the particles that we're going to be doing for 1 and 2. But decay always means that it's on the right-hand side. So these particles are going to be on the right-hand side. And this says isotope produced, which means that it is also a product of it. So this is the general statement. So whatever your isotope is, so for 1, we don't know it. So I'm going to put a blank. Then I put my arrow. Then it says the type of decay is an alpha. I know that alpha is this guy. And then I know that isotope produced is thorium, and this is that mass, so it's 234. And then by knowing it's TH, I'm going to look on the periodic table, and I'm going to find TH, and then I'm going to put that as its atomic number. And TH right now is slipping my mind where it's at. There it is, number 90. And so it's number 90. And then we're going to, so now we just have to solve for this problem. So I'm going to do the top. 4 plus 234, so that's 238. And then we've got our bottom of 2 plus 90, so that's 92. And I'm going to look on that periodic table, and I get U. So my isotope would be U, and then you put its mass, which is 238. So that's problem number 1. All right, problem number 2. Okay, I know what it starts with in this case. Okay, so I know it's hydrogen. I know hydrogen has a mass of 3, and I'm going to put a 1. Okay, then I've got this type of decay, which is a beta. Beta is a high energy electron, so we put that. And then we're going to try to figure out what this other blank is. So I've got 3 equals 0 plus what number? So that's 3. And then 1 equals -1 plus what number? That's 2. And 2 on the periodic table is He for its atomic number. So now for the isotope produced, all I'm going to do is write what it is, which is He, and its dash with its mass, which is 3. And that's how you do all of those on that page. All right, hopefully you have a basic understanding of how to be able to complete this homework packet. Good luck, and ask if you have any questions.